So now we'll be discussing the IUPAC naming of aromatic compounds. Now let us see some common aromatic compounds and their names that have been assigned to them. Alright, so starting with this on the left hand side, we have benzene that we all are aware of. Then if we add one CH3 group to this benzene, the name of this compound becomes toluene. Alright. And if we add an OH to this benzene again, then the name of this compound becomes phenol. Next, if we add NH2 to this benzene, the name of this compound is aniline. Also, if we have COOH present over here, that is the carboxylic acid group, then the name of this compound becomes benzoic acid. So this is benzoic acid. Next, if we have CHO, that is the aldehyde group over here, we call this as benzaldehyde. So benzaldehyde, the aldehyde group. If we have CN over here, then we call this as benzonitrile. So benzonitrile. Then again, if we have OCH3 group over here, we call this as anisole. If we have OH with the addition of another COOH group, then we call this as salicylic acid. Salicylic acid, alright? And the IUPAC name of this will be 2-hydroxy 2-hydroxy benzoic acid. Alright? Here we have another one which OH and CHO group attached, and the name of this compound is salicyldehyde. So this compound is salicyldehyde. Salicyldehyde, alright? And if we see the IUPAC naming of this compound again, then it is 2-hydroxy. So 2-hydroxy, and then we have benzaldehyde. Alright. Next, if we come over here and see that there are two CH3, that is two methyl group attached over here. So the name of this compound becomes 1,2-dimethyl if we write it in common terms. So it is 1,2-dimethyl, and then we have the benzene. So 1,2-dimethyl. Alright. But if we see the name of this compound that has been assigned to it, it is O-xylene. The O here stands for ortho, to which this CH3 is attached. So this is the ortho position, this is the meta, and this is the para. If this CH3 would have been present as its M position, then it would have been called M-xylene, that is metaxylene. And if it were to be present at this para position, then it would have been called as T-xylene, that is paraxylene. Alright. So this is the common names of all the compounds that we'll be using. So instead of calling it as cyclo, and instead of giving the number 1, 2, and 3 to these double bonds, we call this as simply as benzene, toluene, phenol, aniline, and such. And we'll be using all these aromatic compounds, the names, in our IUPAC naming that we'll be doing now. Alright. So let us see some examples. Alright. So if we look over here in this first one, we notice that this is the benzene ring present over here. Alright. And we have CH2 and COOH group attached to this, and therefore we call this as 2-phenyl, alright, 2-phenyl ethanoic acid. Alright, so how did we get this name now? 2-phenyl ethanoic acid. Alright, so here if we see, we have this benzene ring, but this benzene ring is having one valency, which is this valency being occupied by CH2COOH. So here what we do is, if benzene is lacking one hydrogen, we call it as phenyl group. All right. And thus 2-phenyl comes from this. So 1 and 2. All right. So 1 and 2. All right. So here at 2 position we have the phenyl group, and then 1, 2, the carbon has ethanoic acid. So this is how the name of the compound is assigned. All right. Moving on to the next one that we have over here. So in this one, we see that we have the presence of a phenol. All right. And phenol we know was a benzene ring attached with OH. That is, this particular part becomes the phenol, and this now is the substituent. So what is the name of this compound? We call this as 2-hydroxy phenyl methane. So what happens is that the name of this compound comes out to be 2-hydroxy. Then we have phenyl methane. All right. So here if we see this 2-hydroxy comes from, so let us call this as 1 and 2. At 2